Hi folks, in this video we're going to talk about motion in a plane. I'm going to concentrate on constant acceleration problems. Specifically, we're going to do projectile motion. So I'm going to start with a simple example, a stone being projected from the ground. So the first problem is a stone is projected at 40 meters per second at an angle of 30 degrees to the horizontal. So the question is very simply, as it flies, how high does it reach and how far away does it land? How do we do a problem like this? Now the secret to motion in two dimensions is separate the two directions, x and y directions. So first we have to set up a coordinate system. So let's do that. So let's take our x-axis to the right and I'm going to take the y-axis upward. Here are the following steps. If you systematically follow these steps, you will have no trouble solving projectile motion problems. Separate x and y direction. So we start with the initial velocity 40 meters per second, making an angle of 30 degrees with the positive x direction. So the x component of the initial velocity is 40 cos 30 degrees. Cos 30 is root 3 by 2. So this becomes 20 root 3 meters per second. Now the y component of the initial velocity, uy, is 40 sine 30 degrees. That is equal to, since sine 30 is half, that is 20 meters per second. Now for those of you who are confused about when to use sine and when to use cos, I will give you a simple formula. It is always cos. Let me explain. Supposing we have a vector, right? Supposing we have a vector pointing in some direction. And I want its component, let's say in some other direction, in this direction, with which it makes an angle of theta. And let's say the magnitude of a vector is v. The answer is v cos theta. It is always v cos theta. So let's apply this. Here is 40 meters per second. It makes an angle of 30 degrees with the positive x direction. So the x component is 40 cos 30. Let's say I want its y component. So with the positive y direction, the angle it makes is 90 minus 30. So it's going to be 40 cos 90 minus 30. Cos 90 minus 30 happens to be sine 30. So it is always cos. You never need to get confused again. Again, 40 meters per second makes an angle of 90 minus theta with the y direction. So the y component is 40 cos 90 minus theta, which happens to be 40 sine theta. Right. Now what about the acceleration in the x direction? 0. Why? The force happens to point only in the negative y direction. Its x component is 0, so the acceleration's x component is 0. The acceleration in the y direction is acceleration due to gravity. So 9.8 meters per second squared, we're going to take it as 10 meters per second squared. But notice that it points in the negative y direction. I have taken y positive upwards, so this is minus 10 meters per second squared. So with this information, we can write down everything that we need to write. For example, velocity in the x direction, Vx is equal to ux plus axt. So ux is 20 root 3 plus axt, ax is 0. So Vx remains constant at 20 root 3. So the x component of the velocity does not change. So here is another lesson. A force acting in the y direction will not affect the motion in the x direction. Similarly, if there was a force in the x direction, that would not affect the motion in the y direction. Again, the x component of the acceleration and the velocities in the x direction are affected only by the force components in the x direction. Okay, what about Vy? Vy is equal to u plus at. Notice we are just using the same one-dimensional equations separately in the x and the y directions. So v is equal to u plus a t. So this gives me the velocity component in the y direction as a function of time. Now supposing I want to find out when it reaches the highest point. What do you suppose happens at the highest point? Please don't put the velocity equal to 0 at the highest point, because the x component of the velocity is constant. Even at the highest point, the x component is 20 root 3. That doesn't change. But the y component of the highest point is 0. Let me explain why. What is Vy? Vy is the rate at which the y coordinate is changing. Let me write that down. This is very important. Vy is the rate of change of the y coordinate. Similarly, Vx is the rate of change of the x coordinate. So if you look at the y coordinate, just before it reaches the highest point, the y coordinate is increasing. So Vy is positive. Its rate of change is positive. Just after it reaches the highest point, it is coming down. The y coordinate is decreasing. So rate of change of the y coordinate is negative. So Vy is negative. So just before it reaches the highest point, Vy is positive. Just after, it's negative. In going from positive to negative, it has to pass through 0. So at the highest point, Vy is 0. So if I put this equal to 0, I get t is equal to 2 seconds. So it takes 2 seconds to reach the highest point. Now we can ask the question, what is the maximum height that it reaches? The maximum height, take a look at the drawing, is nothing but the displacement of the stone in the y direction. Displacement is given by Sy. Keep in mind, S equal to ut plus half at squared. S does not stand for distance. S stands for displacement. In this case, the displacement of the y coordinate is the maximum height reached. So we can write down the equation Sy is equal to ut uyt, that is 20t in 2 seconds. What is the displacement? Plus half a ay t squared, 4 seconds squared, t squared. So this is going to be 40 minus 20, that is equal to 20 meters. That is the height that it reaches. So 20 meters is the maximum height that it reaches. Now we want to find out how far away it lands. Now ask yourself what happens when it lands. When it lands, it comes back to the same height that it started from. So displacement in the y direction is 0. So I'm going to write it here. So displacement is equal to 0 when it comes back to the same height. Remember, displacement is nothing but change in the y coordinate. Displacement in the x direction is the change in the x coordinate. Displacement in the y direction is change in the y coordinate. Change in the y coordinate is 0. So that is equal to ut plus half at squared. In the y direction, uyt plus half ay t squared. So let's solve this. 0 is equal to 20t minus 5t squared. So that gives me two solutions. T is equal to 0 and t is equal to 4 seconds. Of course, at t equal to 0 also displacement in the y direction is 0. So this is the correct answer. And it also tells me 4 seconds later the displacement is 0 again. So it takes 2 seconds to go up to the highest point and 2 seconds to come back down, a total of 4 seconds. And the question is, how far away does it land? But that is nothing but displacement in the x direction. So let's do that. Displacement in the x direction in 4 seconds is equal to ux t is 4 seconds, plus half at squared. A is 0 in the x direction. So the answer is 80 root 3 meters. That is how far away it lands. This is how we do the first problem. The next problem is even simpler. A ball rolls off a table. How far away from the edge of the table does it land? So let's start by assuming that the table is 2 meters high. Now that's a very high table, but I needed round numbers, so I just took 2 meters. And let's say the ball rolls off with an initial velocity of 10 meters per second. So from the edge of the table, how far away does it land? That is the question. So this is how we do the problem. As usual, set up a coordinate system. I'm going to take x-axis to the right, and again I'm going to take y-axis pointing upward. You can certainly take y-axis pointing down, but I'm going to be consistent in all my problems and take y-axis pointing up. Step 1, set up the coordinate system. Step 2, write down x and y separately. In the x direction, the initial velocity of the ball is 10 meters per second. It's horizontal, so its y component is 0, so uy is 0. Acceleration in the x direction is 0. Acceleration in the y direction is minus 10 meters per second squared. Now the question is, how far away does it land? So the displacement in the y direction is going to be minus 2 meters. Why negative? Because I took y-axis pointing upward as positive, so the acceleration and displacement both are negative. So we can find the time of travel from this equation. S is equal to ut plus half a t squared. So minus 2 is equal to minus 5t squared. So time of travel t is equal to root of 2 by 5 seconds. So during this time, what is the displacement in the x direction? That is the distance from the edge of the table that the ball lands. So Sx is equal to ut root of 2 by 5 plus half at squared. Ax is 0. So answer is this, 10 root 2 by root 5 meters. If you wish, you can simplify this further, but I'll leave it here. This is problem number 2. Our third problem is a very interesting problem where a ball is thrown up with an initial velocity of 40 meters per second at an angle of 60 degrees to the horizontal from the top of a tower 100 meters high. The question is, how far away does it land and how long does it take to land on the ground? So, as usual, we will start the problem by setting up a coordinate system. So I'll take my x-axis pointing to the right and my y-axis pointing up. And our next step is to write the motions in the x and y directions separately. So let's do that. So x, y. So initial velocity ux is 40 cos 60. Cos 60 is half. So 40 cos 60 is 20 meters per second. That's the x component of the initial velocity. The y component of the initial velocity is 40 sine 60. That is 40 multiplied by root 3 by 2. That is 20 root 3 meters per second. Acceleration in the y direction is minus 10 meters per second squared. And acceleration in the x direction is 0. Now in this problem, I am not interested in how high it goes or what is the time it takes to reach the highest point. Straight away I am interested in how long does it take to land on the ground. So now here is the interesting thing. While it's going up, its acceleration is minus 10. At the highest point, the acceleration is minus 10. While it's coming down, the acceleration is minus 10. So this entire motion is one of constant acceleration. So therefore, we don't have to break it up into going up and coming down two paths. I can do it in one step. Keeping in mind that the displacement Sy stands for change in the y coordinate. Now from the start to finish, the change in the y coordinate is minus 100 meters. So S is equal to ut plus half a, which is minus 5 t squared. So we can do this entire problem in one step. I don't have to break it up into two parts. Now this gives us t is approximately 4.3 seconds. Question is, how far away from the base does it land? That is, what is the change in its x-coordinate? The change in the x-coordinate is nothing but sx, displacement in the x direction, which is ut, plus half at squared. A is 0, so straight away you get 86 meters. Problem solved. Well, I'm going to close this video at this point. In the next video, we'll consider more projectile motion problems, very interesting problems where it lands not on the horizontal but on a slope. Bye for now.